I'm Maggie, and I'm going to talk about one of the public lectures I attended, which talked about when galaxies collide, what happens to their supermassive black holes. And it was originally presented by Tamara Bogdanovic. And so, supermassive black holes are just black holes that are distinguished by their mass and their spin. They're only a tiny part of the host galaxy, so they only have a small influence, and they can either be single or binary because triples are unstable. The first stage that happens is the galactic merger. The spatial scale is approximately 100,000 to 1,000 light years. The time scale is billions of years. So this is when galaxies collide and form one galaxy. For example, the Milky Way is going to collide with Andromeda in approximately 4 billion years. And during this time, black holes are placed at the outsides of the galaxies. The second stage is interactions with gas and stars, and the spatial scale is 1,000 to 10 light years. The time scale is millions to billions of years. And this is when black holes collide with other stars, and they lose angular momentum, which pushes them closer to each other, making their radii shrink and forcing them to go toward the center of the new galaxy. And the dust around it can be used to track these black holes. The third stage is gravitationally bound binary. The spatial scale is approximately 10 to 0.01 light years. The time scale is millions to billions of years, and this is when the two nuclei black holes are very close to each other, and they orbit each other like a mixer, and they eject gas to the vicinity, causing low gas density and little matter in the center of the new galaxy. This is very difficult to discover because of the low gas density, and the projected separation is approximately 23 light years. The next stage is gravitational wave phase and coalescence. The spatial scale is 0.01 light years, and the time scale is very short. So this is when the black holes lose orbital energy because they are emitting gravitational waves, and it has never actually been observed because the time scale is so short and it's very hard to track because of the low gas density. And the black holes in the hot gas are getting ready to merge. The next stage is when they merge in a hot accretion flow gas density, and the time scale is approximately 7 to 8 hours. And this creates disturbance in the gas, and the luminosity curve during this time is as follows. So the light is increasing with time because the black holes are getting ready to merge, and they emit more light as they're merging, and then once they have merged, there's a sudden drop-off because it's no longer emitting as much light. And the next stage is recoiling supermassive black hole. The time scale is very small. Black holes give off gravitational waves in one direction, causing the daughter black hole to eject in the opposite direction. And this recoil force from gravitational wave radiation kicks the newly formed daughter hole out of the galaxy, leaving the galaxy by itself with no black holes. However, this is very hard to track, and we need new technology to discover this. And a video simulation of this is... So as you can see, the stages are as follows, and it's just like the galaxies merge, and then the black holes merge, and then the daughter black hole is ejected from the galaxy. So I followed up on this with another article, and when galaxies collide, one of the following usually happens. Black holes emerge, and the daughter black hole is ejected, or the forces caused by gravitational waves are so great that the black holes recoil, no merge happens, and only one black hole is ejected. And in this article, they talked about when one black hole is ejected, which they hadn't considered in the PowerPoint given by Tamara Bogdanovic. And so in this article, they talked about one of the black holes receives a large amount of energy when it kicks the other one outside of the galaxy. And this energy is sent to the disk of gas and dust surrounding it. And this causes it to shine for thousands of years, and we should be able to see it right now. And so I learned about supermassive black holes, what happens when galaxies merge, how supermassive black holes merge, and the effects of their merging. And here are some of the references that I use for my images, my video, and my follow-up article.